Okay, so this is gonna be my last recorded benchmark. I'm not loading up Firestrike or anything like that, but this is actually Linux. So everybody benchmarks graphics or the GPU by graphic intensity by using some type of benchmark, either a game or Firestrike or you know some type of Windows load test. But I use Linux a lot, and I also do a lot of wireless uh, analysis in terms of penetration testing. So one of the tools that's out there's a few of them, but one of them is uh, Pyrit, Pyrit. It's actually a very old program. It's been supplanted by a few other tools. But what Pyrit does, it uses GPU and CPU, all the cores in your CPU, to sort of test, actually to accelerate dictionary attacks. So right now, if you see over here, it's listing my uh, 6 cores and 12 threads, and you can see the temperatures are also listed. So it's a good screen about information about the system. Unfortunately, I should be using more of a screen capture, but I'm a little lazy to go set that up. We're just going to do a straight record off the phone, and we're going to run Pyrit and see what the temps look like on both the GPU and CPU. This is obviously going to max out, well, to the extent possible, uh, the temperature, since now in the loop we're going to have a CPU load and a GPU load simultaneously. You see all the cores shoot up immediately once we do it. All right, so let's run it. All right, so path to cat file, um, home, Zermalo, WPA, and shakes. What's it called? Okay, path dictionary file will be the same path. And the SSID, ESSID. Okay, if I typed in everything accurately, it should be good. Let's try it. Yep. So if you see everything, you see the all the cores usage shoot up. You'll see the temperature shoot up. Uh, yeah. So now core 0 is at 42 degrees. The NVIDIA GPU core is at 32. I should see if there's a VRAM temp setting. So right now, wow, we're at 42 degrees in core 0, 32 degrees in the NVIDIA core. Yeah, if you look at all the cores, they're being maxed out in usage, which is actually really, I think if this program was optimized more, it would even be better to use than Prime 95. But it doesn't. Prime 95 strictly tests the CPU, and it really maxes out the heat. So whatever the difference is in terms of algorithms that this is using, it's not as intensive as far as heat is concerned as Prime 95. But also maybe because it's also using GPU acceleration, it doesn't concentrate on the CPU intensity. There's another actual dictionary attack program which strictly uses CPU intensity. I should try that out, see what temperatures we get. Now remember, we maxed out I think around 50 using Prime 95. So far we're up to 46. Now this, I would imagine, should get harder because we're both using well, not harder, but it should get relatively warm since we're using both GPU and CPU acceleration. So this will probably run this dictionary with my CPU, and this program runs for probably about, I don't know, 5 to 7 minutes before it either finishes or finds the password, which is relatively, I don't remember about this particular ESSID, but I think it does find the password probably close to around 5 minutes. But either way, I mean, you could run it forever. I mean, the chances of actually finding a WPA handshake is very limited unless the password. I mean, this is a known password, but unless the password's very stupid. So, but it's a good test. And it's a benchmark I would like to see more of. I mean, just me personally. This is actually a useful program if you are into pen testing, or any of the newer programs which replaced it. I like this program because it's strictly focused. I mean, it focuses on both the GPU and the CPU. Whereas Hashcat, the other popular program, it's either or. There's a version for the CPU and there's a version for the GPU. It's actually much more efficient than this. I mean, the algorithm, however you wrote it, it's usually updated and optimized. So it runs through, I would say, about 50 to 60% faster in period, even with using the CPU acceleration. I can't wait to get the 6950X, where you're going to see basically 20 cores up there. That'll be pretty interesting. Oh, let me take this off the stand. You can see what's going on. All right, so there is the core count and core usage. Okay, this is a program, or app I should say, called Corky on Linux systems. So it's actually very customizable. This is pretty much the way it comes stock. And it tells you a lot about the system. So it tells you your disk, your internet usage, your CPU usage. I think GPU is somewhere on there, or it could be if it's not. This is the word list right now that the program is running through. You can see it's going 1,000 at a time, at least what it prints out. Over there are our temps, so we're up to 50 degrees on, well, the physical ID I assume is the motherboard. That's the motherboard temp, and 47 on the core 0. So that's close to where Prime 95 was giving us. And the GPU core is about 38. Now the VRAM is what really gets hot on the GPU, so I gotta find a way to print the VRAM temperatures. Let's take a look, and this is just more information. I mean, good thing about Linux, there's a lot of little disklets that give you information about the system. It's awesome. If you don't use Linux, you should, or at least you should dual boot. There's no reason not to, with the amount of drive space we have these days. It's hard to focus in on those words, huh? Alright, so those are the words. Dictionary, just going through. I forget how big the dictionary is, but it's going to go through all the words until it finds or exhausts the dictionary. Okay. We're still here. The computer's still here. Now I have noticed that fan issue again. Once the CPU ramps up, it seems that, I don't know. Once the CPU ramps up, the fans go down. I gotta figure out what the hell is going on there. Oh, there's the phone. Nothing important. I'm just adjusting this. Alright, let's see if we can get a little better picture there. Alright, so far we're up to 52. Wow. I mean, on the ambient temperature. And core 0 is about 50 degrees. Again, wow, and the GPU core is up to 42, about 42 degrees. So yeah, things are running relatively warm. I mean, relatively, it's still decent. That looks like stock air temperatures. Again, though, it's a pretty cold day. I think once I stick the second rad in there, we can probably lower these by about, hopefully about, I think we can lower this about 5 degrees. That might be asking a lot. And also better fans. The fans I got in there suck. All right. Yeah. So it actually did find the password. It's one of those passwords I actually put inside of the dictionary. Oh wait, actually no, it didn't find the password. It said unable to identify the password. Okay, so it exhausted the dictionary. So this dictionary has what? About if you look at what it says, it went through. It's hard to see, but if you look at what it says, it went through about 3,360,000, or is that 30? Let me see. Looks like 33,631,516 passphrases that it tested in 449 seconds, and that comes to about 47,000 passphrases per second. Now you may be thinking that's pretty slow, but if you know anything about this particular algorithm that WPA uses, it's called the password base key derivation function 2, or PBKDF2. I've actually coded that algorithm once. It's pretty interesting. It uses other algorithms within it, the SHA 256 and a few other things. But one of the things it uses purposely to slow down dictionary attacks. It uses